This is Mr. Alexander, and I want to work through this Unit 2 test review with you. So let's get right to it. First question is a word problem. The rectangular patio shown in the diagram below is enclosed on three sides by a fence. So it's this patio right here. The area of the patio is no more than 350 square feet. The total length of the three sides of this fence is no more than 85 feet. Three sides, that's probably important. Write a system of inequalities that can be used to find the values of L, the length, and W, the width, that will satisfy these conditions. So to find area, that's length times width. So length times width, and we know that the area can be no more than 350 square feet, so that needs to be less than or equal to 350. And we also know that the fence is no more than 85 feet, so that pertains to the perimeter. But the perimeter of this thing is just these two widths and this one length. So that's going to be one length plus 2W has to be less than or equal to 85. Now it doesn't say solve anything, it simply says to write the equations, which is what we've done here. So looking at number 2, it says a craftsman wants to spend less than $400 on supplies for making bracelets and necklaces. Supplies for one bracelet cost $7 and supplies for one necklace cost $9. This relationship is shown in the graph below. Okay, the craftsman needs to make at least 10 more bracelets than necklaces. Find one point that is a reasonable solution. So if I was to write that as an equation, the craftsman wants to make at least 10 more bracelets than necklaces, then I would say that the number of necklaces is n, and we want to add 10 to those because we want the number of bracelets to be 10 more at least. So that means the number of bracelets has to be greater than or equal to n plus 10. Now if I'm going to graph that, I need to subtract the 10 to get n is less than or equal to b minus 10. So if I graph it, the negative 10 is the y-intercept here. And it's down here so you can't see it, but if I plug in some points, 10 minus 10 is 0. So 10, 0 is a point. 20 minus 10 is 10, so 20, 10 is a point. 30 minus 10 is 20, so 30, 20 is a point. And this is a solid line that is shaded below. So the shaded area, the area that's shaded twice, is the solution set, and I can take any point in there and make that a reasonable solution. So I like this one, 30, 10, 30 bracelets, and 10 necklaces. But I could have picked anything in the shaded region right here, like 30-20 or 30-15 or 20-10 or 40-10. All of these are acceptable solutions. That's just one of them. It says pick one, so I did. Okay, question 3. Chacos is a dish made from wheat, sugar, and cocoa. Bertha is making a large pot of chacos for a party. Wheat, W, costs $4 per pound, sugar costs $5 per pound, and cocoa costs $3 per pound. She spends $42 on 12 pounds of food. She buys twice as much cocoa as sugar. Write a system of 3 equations that represents how much food Bertha has purchased. So, if we are just to take the wheat, the amount of wheat in pounds, plus the amount of sugar in pounds, plus the amount of cocoa in pounds, and I add them all up, how many pounds would I have? I'd have 12 pounds of food because that's what they told me right here. Now she spent $42, and I know that wheat costs $4, and sugar costs, let's see, $5, plus the cocoa costs $3. That's a C. And the amount she spent was $42. There's 2 of my 3 equations. Now the last one's the one that people get tricked on. She buys twice as much cocoa as sugar. So cocoa equals sugar times 2. Now you might be asking, why is the 2 in front of the sugar? It says cocoa, she buys twice as much cocoa as sugar. So shouldn't we multiply the cocoa by 2? No. Think about it this way. If she buys 1 pound of sugar, then she should have 2 pounds of cocoa because she buys twice as much cocoa. So if I plug in a 1 here, it spits out a 2 for cocoa. So that's why we put the 2 in front of the C. Now it doesn't say to solve this, it just says to write the equation, which we've done here. So we're done. Let's go on to number 4. Citrus Farm sells boxes of navel oranges for $9 and boxes of grapefruit for $12. The farmer wants to earn at least $4,000. Write an inequality that represents this situation. Okay, well, let's see. Grapefruit costs $12 and oranges cost $9. So if I did $9 times oranges plus $12 times grapefruit, he wants to make at least $4,000. Now the inequality that represents at least, that means this needs to be greater than or equal to $4,000 to get at least $4,000. And that again is just writing the equation. Let's go on to number 5. Tom has a collection of 27 CDs and Nita has a collection of 18. Tom is adding 3 CDs a month to his collection while Nita is adding 6 CDs a month to her collection. Write, graph, and solve a system to find the number of months after which they will have the same number of CDs. Let X represent the number of months and Y equals the number of CDs. Let's do Tom first. Tom's CDs, he has 27 CDs. He's adding 3 CDs a month. So Y equals 3X, because X is the number of months, plus the 27 he started with. And Nita, she has 18 CDs and she's adding 6 per month. So Y equals the 6 CDs she's adding a month plus the 18 she started with. So if I go ahead and graph these, I'll start here at the 27, and it's 3x plus 27. So that means I'm going, for every 1 year it's going up 3. So if I start at 27, it should be at 30, and then 33 the next year, 36 the year after that. So this is Tom, and that last point is 336, just in case we forget. And Nita, she starts out with 18, and every year she's going up by 6. So 18 goes up to 24, 24 goes up to 30, and 30 goes up to 36. So here's the Nita curve, and she goes through 36 as well. So we're supposed to find write, graph, and solve. Okay, I graphed them, and I solved them. The number of months after which they'll have the same number of CDs. At 3 months, they both have 36 CDs. And that's the solution to that one. It's where they cross. Let's talk about number 6. The sum of 2 numbers is 98. Their difference is 18. Write a system of equations that describes the situation and then solve to find the 2 numbers. Okay, so x plus y, the 2 numbers, they add to 98. And then the difference is 18, so that's going to be x minus y equals 18. Now, I'm going to choose to solve this as a matrix in the calculator. So the coefficient in front of the x is 1. In front of the y is a 1 and a 98. 1, negative 1, 18. This is a 2 by 3 matrix, and I can just solve this in the calculator, which I'm about to do right now. Let me get this so you can see it. Okay, so I'm going to turn it on. We'll go to the matrix screen, go over to edit. This is a 2 by 3 matrix. The matrix is 1, 1, 98, 1, negative 1, 18. I'm going to second quit out and go back to the matrix screen, go over to math, up to B, go back to the matrix screen, hit enter on A, and the solution, the 2 numbers are x equals 58, y equals 40. X equals 58, y equals 40. Those are two numbers that add to 98, and their difference is 18. All these solving ones you can do using the matrix, which I recommend you do. You can use Gaussian elimination if you'd like, but I don't recommend it. Okay, moving on. Kendra owns a restaurant. She charges 40 cents for 2 eggs and 1 piece of toast, and 30 cents for 1 egg and 1 piece of toast. Write and solve a system of equation to determine how much she charges for each egg and each piece of toast. Let x represent the number of eggs and y represent the number of the pieces of toast. X represents eggs, y represents toast. Okay, great. So we can start with the x. All right, so let's see, 40 cents for 2 eggs and 1 piece of toast, and 30 cents for 1 egg and 1 piece of toast. So, okay, 2 eggs is 2x, and 1 piece of toast is 1y. That equals 40 cents, and 1 egg and 1 piece of toast. That equals 30 cents. So I'm going to do this in a matrix again. And we're going to find out how much 1 egg and 1 piece of toast cost individually. So it's going to be 2, 1.4, and 1, 1.3. We're going to go back to the matrix screen. We're going to do this in the calculator. Okay, so second matrix, edit, and this is 2, 1, and 40 cents, 1, 1, and 30 cents. Second quit, second matrix, over to math, up to B, second matrix A. 1 egg costs 10 cents, and 1 piece of toast costs 20 cents. That's it. That's number 7. All right, I'm going to go over to the next page, and we're going to talk about number 8 next. Number 8 says, write an inequality that can be represented by the graph below. All right, so it's going to be it's a solid line, so it's greater than or equal to, because it's shaded above and it's a solid line, so that's greater than or equal to. The slope of this thing appears to be up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it's just an x, because the slope is 1, and then the y-intercept is b, so it's just b. And I think that's the equation. It's just y is greater than or equal to x plus b. And it's an x because the slope is 1. And I don't know what the b is. So if that was a 1, there'd be a 1 right there. If it was a 4, it'd be a 4 right there. So I think that's the equation. Let's talk about number 10. Solve the system of inequalities by graphing. All right, well, I can graph this first one. Y is less than or equal to x minus 1. Start at minus 1, and an x means go up 1 over 1, up 1 over 1 a bunch of times. And we can go ahead and make that solid line. It's solid because it's less than or equal to. So I'll go ahead and draw in that line. And I'm going to put arrows on that line. And it's less than or equal to, so I'm going to shade below. Okay. And now this next one is 7x plus y is less than or equal to 4. I'm going to solve that for y so I can actually graph it. So it's going to be y is less than or equal to negative 7x plus 4. I just subtracted the 7x from both sides. So plus 4 is a y-intercept of 4, and minus x means I go down 7, right 1. 1, 2, 3, 4, 5, 6, 7, right 1. And that's a solid line because it's less than or equal to. And so I'll shade everything below this line. And the question is, what's the double shaded region? And that's going to be this stuff right here. This is the solution space. Because I shade this region